design, which uses the progressive approaches with engineering. The book focuses on how digital fabrication technologies are used by the architects in the construction industry. Digital fabrication offers a range of informed opinions on the subject, written by some of the leading authorities in the world. It addresses new digital fabrication technologies such as 3D printing, laser cutting, bandsaw cutting, stitching, weaving, forming, bending, folding, and stacking. The volume is divided into sections comprising manifestos, methodologies, interviews, and projects, and also includes a helpful introduction with a brief history of digital fabrication. Digital manufacturing is a process where manufacturing methods are computationally defined with either subtractive or additive construction. Subtractive and additive processes can be used to create tectonic elements of a larger form. Additive manufacturing refers to an approach to manufacturing which builds upon hardening of a material which is formed with the productive approach. 3D printing is an example of additive approach to manufacturing. There is an expanding field of research investigating alternative materials for 3D printing. Subtractive manufacturing is a method whereby the production techniques remove material from the original mass. This process can be used to create tectonic components of a larger form. CNC, computer numerically controlled manufacturing, has been derived from the aviation industry. Patrick Tai produced an installation in SciArc in 2011 with subtractive forms using CNC milling on foam and an industrial robot to produce a cave structure. CNC milling is a subtractive manufacturing approach which is used to create a tectonic element which will come together with other elements to produce a larger form. Through the development of systems and intelligence with the understanding of processes of digital manufacturing, we will be able to produce efficient methods of manufacturing for prototyping and detailing construction elements at different scales. Patrick Schumacher writes, "Tectonism is currently the most prevalent and promising subsidiary style within the overarching paradigm and epochal style of parametricism." He then continues to explain the importance of coding with its architectural complexity as a tool for sophisticated generative design. Philip Fyuan has written, "Robotic systems will revolutionize the future of construction." He outlines the new processes that can now be designed to be performance-driven. Utilizing performance analysis software available with 3D modeling software such as Karimba or Kangaroo, it is now possible to use generative design for structural optimization. Frei Otto is noted throughout the book for his physical structural performance form-finding analysis experiments which he produced. Digital Fabrication, written by Philip Fyuan, Achim Menges, and Neil Leach, is a sophisticated in-depth analysis of digital fabrication techniques for architectural application. The book contains contributions from the world-leading experts in the field on a variety of subtractive and additive manufacturing techniques. The book is separated into sections containing information about manifestos, methodologies, interviews, and projects that have used digital fabrication within construction. Achim Menges, whilst writing about the morphogenic approach to design, discusses the potential for materialization of computational fabrication methods. He writes, "Technological innovation required by nature an interdisciplinary approach to design. The morphosis of space requires a theoretical and prospective application of parametric systems, which are used to determine the methodological framework for the fabrication techniques to produce convergence of synthesized construction." The book is written as a series of academic texts written by the leading industry professionals in digital fabrication and manufacturing. Robotic fabrication provides the opportunity to expand substantially the material practice of the discipline and to renew the constructive knowledge of architecture from the inside out. Jan Willeman, Fabio Gramzio, Matthias Kohler Gramzio from Gramzio Kohler Research in Zurich have stated, "There are new possibilities which have been developed with the vertical manufacturing which will streamline the development and production of architectural systems through automated manufacture." The installation of the Armadillo Vault by Philip Bloch, Matthias Rittmann, Tom van Mel at Block Research Group in Zurich created a stone-cut vault which was exhibited in the Venice Biennale in 2016. This exhibition was also held in a protected ancient building which could not apply a greater force than 600 kilograms meters squared to the floor at any given point. This project highlights the potential for stone compression engineering with CNC stereotomy. A waffle structure timber frame was created to support under the hold the structure during this construction, prior to removal and relaxation into a compressive structure. Within the machine, which cuts through the stone with a subtractive reduction, there was a machine tolerance of 0.4 millimeters, and through considered and careful handling of the construction of this advanced structure, it was possible to build it with all the constraints as a result of computational organization. Achim Menges, ICD from the University of Stuttgart, has created shelters from timber using panelized modulation to create enclosures at the ICD ITKE Research Pavilion in 2011 at the University of Stuttgart. It's an example of a tectonic system where the panels of CNC rounded timber are assembled to form an enclosure using a generative process of relaxation of the individual surface elements to create a series of surfaces that span the external face. The method which he uses is an alternative approach with timber material, as can be seen with IDC ITKE Research Pavilion in 2010. The Landesgartenhau exhibition hall envelope is completely made of lightweight timber shell which is CNC routed into 243 panelized plates containing 7,600 individual finger joints. Each of them has been made with a robotic arm and a turntable which rotates the timber. The Timber Tectonics project of 2016 for the Digital Futures exposition showcases a 1-to-1 scale that is CNC cut. The structure has the potential to be used as part of a structural system for the timber glue laminated structural technology. Carimba was used in order to optimize the structural capabilities of the material efficiency. A robotic arm was attached to a bandsaw and was used as a production technique for these timber elements. The MIT Sean Collier Memorial, created by Jae-min Jeon, Eric Howler for Howler and Yoon Architecture, is a structure which displays unity. It's divided into 5-way stone vault arch by a large-scale stone saw. The stones have been divided into sections to form a tectonic fabrication with 3.5 meter rotating blade that has a tolerance of only 3 millimeters. Smaller elements are then precision engineered with a robotic arm and a CNC milling machine to a tolerance of 0.5 millimeters. La Voûte de Lefebvre, created by Brandon Clifford, Wes McGee at Matter Design Studio, uses a catenary structure as a base geometry derived from anchor points and arch columns subdivided into a series of hexagonal forms to create a spatial configuration within the space which stands in compression. This is a tectonic modulation with subdivided elements, a computer numerically controlled process from which subtractive process removes material to create a lofted arch geometry. G3DP additive manufacturing of optically transparent glass, mediated matter group at MIT Media Lab and MIT Glass Lab have developed a process of 3D printing glass that comes out by heating 2 chambers of molten glass simultaneously to a temperature of 1900 degrees and can contain sufficient material to build a glass element of a larger building form. 3D printed glass possesses an opportunity for ingenuity in the future developments of building. This book provides a detailed and informative overview of many cutting-edge projects which use alternative manufacturing techniques for the optimization of design in construction and architectural applications. It presents solutions for changing manufacturing approaches through implementations of strategies with systems of production. We're living in a context where it's integral for us to use the manufacturing techniques available to produce tectonic systems for elements of buildings and manufacture on site. New advances in engineering techniques and approaches has been applied to an architectural context. As designers, we have a responsibility to inform ourselves with the most advanced forms of engineering technology for us to create approaches to applications for this in our projects which we design.